So let's give it 1.1.20. You will learn what is this, what are the rules and all in your course. Okay. Let's leave this blank for now. Okay. And let me give it, no problem. Okay. So let us just go here, close this. Okay. Now let's go here and let's say, let's open a browser and let's give the IP address. So it was 1.1.20. Okay. Now we'll get this. Welcome to TNDC. Okay. So what happened here is if we go here and if I just go to the simulation mode, I will remove all the protocols. Just 1 second. My mouse is not moving. Okay. Let me do this. One second. Okay, so let's once again open here the browser and let's open the web page. So we'll see the packet flow. So 1.1.20. Okay, so here is the packet. So let's move forward. So here you can see the packets are getting moved. Okay, so you can see the packets. Okay, so we will see what packets are here and everything. Just give it a second so that it completes the process. Okay, now we'll just stop this. Okay, now if we go here, some PC12 server 0. Okay, so you can see how the packets move. So there was an Ethernet. So this is the Ethernet link. Okay, on top of it is the layer 2 protocol. Okay, so this is asking for the MAC address. Then the layer 3 protocol comes. Okay, so 1.1.10 and destination 1.1.20. Then on top of it, there's a web server which is listening on to it. So there's a layer protocol and layer 5, layer 6, layer 7. Layer 5 is combined with layer 4 in the real world, and layer 6 comes along with the layer 7. So HTTP is working. Now the problem with this design is, okay, so let me go back to real time. The problem with this design is I now have another PC. Okay, now I want to connect to the server, but this server has only one port. Okay, has only one port. Or let me take the crossover cable. Now I have only one port. See here, no available ports. So what to do in this situation? Okay, and let's first solve this problem and we'll solve some other problems later. Okay, so let me just delete this. One second. Just a second. Okay, now let's come here and how to solve this problem. So there are two ways to solve this problem. Okay, the first one is we have to bring in some other device here. Okay, so usually you might have seen this, some of you might not have seen this. So there is something called as a hub. So if I get a hub here, okay, and if I connect these two together, so I'll connect PC1 to this hub and I'll connect the server to the hub. Okay, and also this server, let me name it something. Instead of server 0, let me if you can stop chatting, it will be better because it's blocking my screen. I can't type. I have to close. Okay, so instead of this, I'll say Google. Okay, and let me close this. Okay, now I have connected these two to the hub. So also let me connect another PC. Okay, and the problem with this, okay, let's solve this problem. So now if PC3 wants to communicate with Google, it can do it. If PC1 wants to communicate with Google, it can do it. But what, okay, let me add another PC here. Okay, let me bring in another PC and let me add this. Okay, now we have three PCs, so PC1, PC3 and PC4. Okay, now what happens is, say, imagine this is your principal or your instructor is designing a question paper for you. Okay, some examination question paper. Okay, so a test question paper. So that should not be seen by, these are the PCs which are used by students. Okay, and this is the server. So what the faculty member is doing is he is trying to upload this question paper to this server. Okay, Google. So but these two students, the students who are sitting on these PCs, they should not be able to see this. So we have used a hub here. Okay, now let's say what happens. So if I go to simulation and let me save this. Okay, just give it a second. Okay, now okay, now if I come here and if I just open this once again and let me go here and let me press enter. Okay, you will see the packet flow. Okay, so it goes to the hub. Okay, now what hub does is whatever packet it receives or whatever electrical signal it receives, it pushes on to all the other ports except on the one it received. So this received on FA01, so it will push on FA02 and FA3. Okay, now even though these PCs will not process, okay, but what is happening is these devices can see that packet. Okay, can see what is inside that packet. That is one security problem. Second is it will increase the traffic. It is a performance issue. Say some 100 students are there, okay, and if 100 students are there, what happens is if 100 students communicate, lot of this traffic will happen, a lot of traffic will come into the network, so others performance will also be affected. So it's like there will be a lot of collisions, there will be a lot of traffic. So hub is not an ideal solution. So we need some other device which will prevent this. So which will prevent the traffic going to other systems. It should go from source to destination. It should not go to other systems or other people who are using the systems for which the traffic is not destined to. Okay, so it's not addressed to. So what we'll do is we'll come here and we will go to real time. So instead of this, we will use some other device. That device, let me remove this. Okay, so we have three PCs. So we'll come here, we'll use another device called as switch. Just give me a second. Okay, 1 second. Okay, I'll drag this switch. So this is a switch. Now, if I open this, okay, and if I open the switch, you can see this is how switch looks. So there are a lot of ports. So I connect each of these PCs to this port, okay. And what switch does is it will actually prevent traffic going on to other ports. In normal conditions, it will not allow traffic other than from source to destination and the return traffic from destination to source. So what we'll do is we'll once again connect this. So we will connect fast Ethernet 0 to switch the first port. We'll connect PC3 to 1 second. Connect fast Ethernet 0 to fast Ethernet 2. Connect PC4. Yeah. Okay. And we will connect the server. Okay. Now, this is a very simple design. So now let's see what happens. So let's go to let me save this. Okay. And if I go to simulation and let's do this thing. Let's go once again from the server. So let's see. So this the first packet is something called as ARP packet. It will be sent, but once it gets the address, it will not be sent. Yeah. So it will move directly from here. It's moving from server to PC1. Okay. Now, what is the problem? Okay. Now, still we have not solved the problem. So this is instructors PC. Okay. And these are students PC. Okay. I want instructors PC. So another instructor joins. Okay. So PC1. So PC5 is an instructor. So his network joins, his computer joins the network. Okay. And now these two people want to communicate with the server. Okay. And these two are students who are actually doing something. So now what happens is only these two should communicate. Okay. And let's bring in another server. Okay. Let's bring in another server and let's connect this. Okay. Now PC1 and let's call this instructor server or academic server, ACAD server. Okay. Now PC1, PC5 and ACAD server. Okay. So PC1, PC5 should interact with ACAD server. Students should not interact with ACAD server. Okay. Now students should only interact with Google. So what to do? Okay. So we'll go to the switch. Don't worry if you don't understand the commands. That's not the point of this. Just understand the design. 1 second. Okay. Now if I come here, so let me just drag this. Okay. Now what I will do is, So this is connected to FA01, this is connected to FA05, this is connected to FA010. Just think that this is the port number. This is connected to port number 1, this is connected to port number 5, and this ACAD server is connected to port number 10. So I will create a virtual thing there. So I will create a virtual switch on top of the normal switch. So how to do that? So I will say let's call this virtual LAN, and let's call this VLAN 10. Okay, and we'll say the description or name is instructor or ACAD VLAN, ACAD server, ACAD VLAN. Okay, now in this ACAD VLAN, so what we'll do is we'll say the systems which are connected to this ports. So let's say interface FA01, FA05, FA010. Okay, they are connected to ACAD VLAN. Okay, so the rest are connected to VLAN 1. So VLAN 1 by default. So we can also change that. So we can go and say FA02, FA03, and FA04, they are connected to another VLAN. Okay, so VLAN 20. I'm not going to do it. I'm just showing you an example. Okay, now if I do this, okay, now let's come back. Let's go to simulation mode. And if I go to PC1, and if I anyhow, this will not work, but I just want to show you because this is in a different VLAN. But see how the traffic moves. The traffic should not go to PC3, PC4, and Google. Let's see where it goes. See, it goes to only those two paths which are part of that VLAN. So even though I have not addressed that, the addressing is different, it will not work. Okay. So if I want to do that, I have to give a separate addressing and then make it work. Okay. Now let's say, let's come back to real time. So I will remove this these PCs. Okay, I will also I'll also remove this server. Okay, now what I will do is I will make I'll remove that VLAN also. I don't want that VLAN. Let everything be in one VLAN. Okay, it's not a, or let it be there. So let's solve another problem and then we'll remove it. So what I will do is I'll let's say, so this, if I go here to the physical view, okay, so this is how physically it looks. So now if I go here to navigation panel, intercity, so if I go to the rack, so this is how it looks. So everything is in one rack. Okay, so everything is in one rack. So this if I go back here, and if I see here, all this PC, everything, they are connected very closely to one rack. So this is the rack. Okay, they are connected to this rack. Now imagine, so imagine, let's go back to logical thing. Imagine this server is in another building. Okay, so the cable length has a limitation. So say for example, in most of your colleges, you have admin building, and your college, your classrooms will be in a very different building. Your labs will be very far off from your classroom, usually. So I have to connect this server which is in a different building, and all your PCs are in a different building. So how to do that is I have to get another switch. Okay. So when I get another switch, so I will remove this link. Okay. Now another switch, I'll get in another switch here. So I will just say 29. One second. Okay. Let me get in another switch, and I'll connect this switch. And I'll connect switch to a server. Okay, let me make it quickly. So this is in a different VLAN. Okay, this is in a different VLAN. So what I will do is I'll just, so that you can see the packet flow, what I will do is I will just close this. One second. I will remove the IP address, or let me do this way. Anyhow, I'll remove the IP address, so that will be faster. And I'll give the same IP address to PC3. So I'll come to PC3 and I'll give it an IP address. So let me give it a different IP address. So let's say 1.1.100. Yeah. So 1.1. Sorry, 255.255.255. Yeah. And then 1.1. Okay. Now if I do this, so, and also what I will do is I'll go to the switch. And now what is happening here is I have to tell this switch that you have to carry multiple VLANs. Okay. To do that, it's very simple. I will say, remember in your old days you had trunk lines. So if you see old, let me open Google. So if I say old telephone exchange, just to show you the concept of the trunk, how it looks. This is so all of you right now also in your present day world, there will be a big server which will like this. So here this is a trunk. So they used to connect the telephone lines of one exchange to another exchange so that they can carry traffic of multiple subscribers. So if I am calling Anurag and if Ram Gopal sir is calling Anurag, Ram Gautam sir is calling Anurag, so then what happens is both of our traffic, or Ram Gautam sir is calling Naveen. So what happens is the traffic should flow. All your traffic should flow. So these are the trunk ports. So similarly in the network, so say here they are connecting. Now it's all automatic, all software driven, software controlled trunk lines. But in the initial world, so like this. So they used to connect one network to another network, connect another network to another network. So these are not, first of all, these are not compute telephone lines. These are network data lines. So now we have to tell this that you have to carry multiple VLAN traffic. So this is in VLAN 10. So just okay. Now if I come here and if I open, and what I will do is I will go to Internet FA04 and I will say switch port mode trunk. One second. Switch mode port trunk. Okay. Now the trunk port will be up. Okay. So now this, if I go here and don't worry about the command, just understand what is happening. Now if I say show interface trunk, it will say I can carry both VLANs 1 and 10. Okay. Now if I come here and if I go to the browser of PC3, and now if I open the browser, just give it a second, the browser will open shortly. Okay, now if I give it the IP address of our server 1.20, now it says welcome to TNDC. Okay, but how the traffic is flowing? So if I go here and if I just come here and if I say do it once again, and if I move, you can see the packets come over. Okay, so initially they will do something called as R, so don't worry about that. Then it will be a complete networking class if I start to explain that, so that the traffic comes back. Now let's come back to our design. Okay, now the issue is, okay, now this server, okay, your colleges, say for example, you have a college in one city and you opened a new college, means the same institution, they opened another college in another city. Say your college is in Chennai and they open another branch of that college in Madurai, and they moved this server to Madurai. So I can't run a cable from here to Madurai. That will be very costly. So I will use some other network to connect it. That's one question. That is one part of the solution. And the second part is I have to use a different address, means I have to use a different IP address. So for Chennai, they have given this 1.1.0. So here for Chennai, it's 1.1.0. Okay. And so somewhere, say, let's open Notepad, so that you can see it. So for Madurai, they have given 4.4.0. Okay. So how to design that? So first of all, this server, let me remove the link. I don't want to remove the server. Okay. Now, this server which was here, now it has moved somewhere else. So it's somewhere here, suppose. Okay. And also let me remove the other PCs. We don't want unnecessary cluttering. Okay. Now let me remove this and just continue. Okay. Now we have two PCs. This is 1.1.0 network. Okay. And we have the trunk port and we have one switch, but this has moved to a different thing. Now you contact, like how to connect the server in, means your network in Chennai to a network in Madurai. How to do that? So you'll inquire what are the possible ways. So you have to use someone who has already laid a cable. So it can be telephone networks, it can be railway network. Usually the railway network, they started it in India, but it is not that successful. So you ask your telephone networks, since you already have a network, means you are already connected, say Chennai to Madurai. Okay, so can we use your network? They'll say yes. So, but first of all, you have to connect your router to our router. So in Airtel says we have an office in Chennai, so you have to connect from your Chennai headquarters, means Chennai institution, from there to Airtel Chennai. Okay, and Airtel Chennai has a router, and your college has a router in Chennai. So you have to first connect that. So then they will say, okay, then you will say, okay, I'll get a router. What is the addressing scheme? So first we'll get a router. So router connects, very simple, router connects to different networks, two or more different networks. Okay. So let's bring in a router here. So let's say 29. So you will get one router. Okay. Now I have to connect this to this Chennai thing to this router. Okay. This is our router. Okay. And Airtel has another router. And Airtel, this router connects to a router in Madurai. Okay. And from there, we can also do something. So let's say, and let's say this is your thing. Okay, let us name this to understand it better. So then we'll complete the network. So this is your default router. Okay. Then you have, say, Airtel Chennai. Is voice not audible? Ram Gautam sir, can you hear my voice?
Yes, sir. Yes.
Then we'll call this as Airtel Madurai. Then this is your Madurai. Okay, instead of default router, let's call this Chennai router. Chennai ACAD router. Okay. Then I will call this Madurai ACAD router. Okay. Now, what? Okay, let us first connect this off. So let me connect this. Also, let me save this. Okay, then let me connect these two. So from Chennai ACAD router, you connect Airtel Chennai. Then you connect from Airtel Chennai to Airtel Madurai, a fiber cable. Okay. Then from there you connect Airtel Madurai. You connect to your Madurai ACAD router. Okay. Then from your Madurai ACAD router, you connect to a switch. So let me just drag the switch here. And let me bring the server here. Okay. And let me just connect this Madurai ACAD router here. And from here, let's connect to the server. So what I will do is I will also have this server run something called as DNS server. So I don't want all the IP addresses. I just want to use the name. Okay. So I will just go here. I'll change the IP addressing, but so let me go to services and let me go to DNS. And let me give this, okay, let's come back to this because I need an IP address. First, let's give this a naming. So this will be 2.2.0. So in real world, it will not be 2.2.0 or 1.1.0. It will be what your service provider gives you, and in your internal network, it will be private addressing. Okay, but just this is for explanation sake. Okay, so this will be, let it be 2.2.0. This network which connects, let me move this. Okay, this network will be 2.2.0. Let me delete this. Okay, so this will be 2.2.0. This Airtel Chennai to Airtel Madurai, that will be 3.3.0. So just let me get this here. So this will be 3.3.0 / 24. And let me drag this a little bit. Okay, so that you can see. Let me drag this also, you can see. So this will be from Airtel Madurai to Airtel, means your Madurai ping router. So that will be (4.4.0 / 24), and this will be 5. Okay. Now, how much time? So let's not do DNS. Let's continue without DNS. Okay. So I'll explain. Let me add that entry. So in case, so let me say 5.5.5 is the address, and I will say this is www.tnsdc.com. Okay. A record add, and then I will come one by one and see if whether it works. Okay. Okay. Now I have to address this first. Okay. So now this is 1.1.100, I suppose, PC3. So in the real world, you have to see whether all your addressing scheme is there and all those things. So let me open. And if I go to desktop, and if I go to config, I have to close this. So let me close this browser for a second. And if I go to this thing, so this is 1.100, 1.1.1. So DNS server, I will just give it as 5.5.5. Okay. And our web server is also 5.5.5. Okay. So now I will come to this this router, Chennai router. So what is happening is I have to tell Chennai router, Chennai ACAD router, that okay, so this is, I'll turn the interface on and I will say, so this interface, if you see properly, so this is gigabit Ethernet 0 and this is gigabit Ethernet 1. So I have to tell that this is 1.1.1. So you're part of this Chennai router and your address is this, and I will give it a subnet mask. Okay. And for the other router, gigabit Ethernet 01, I will say this is 2.2.1 and this is 255.255.255.0. Okay. And what I will do is I'll also save this. I don't want it to crash and sometime. Okay. Now I will also come to gigabit Ethernet. I'll come to Airtel Chennai, and Airtel Chennai, if you see here, so this is connected, gigabit 01 is connected to Chennai router, and gigabit 000 is connected to the Airtel network. So once I come here, I will say I'll go to gigabit Ethernet 1, which is connected to the Chennai, our network. So I will say this is 2.2.2. Just give me a second. I'll say this is 2.2.2 and this is 255.255.255.0. Okay, and I will go to the gigabit Ethernet 0 network and I'll give it an IP address 3.3.0 because it's connected to Airtel net. This is 3.3.1 and this is, let me just say 255.255.255.0. Okay. Okay. Now Airtel Chennai is, now I have to go to Airtel Madurai. So Airtel Madurai gigabit 01 is connected to 3 network and this is connected to 4 networks. So I have to do that quickly. So I'll go to Airtel Madurai. Let me say whatever I have done. So let me drag this side. So gig 1 and gig 0. Okay. Gig 1, I will name it as, I'll give it an IP address 3.3.3. Okay. And for gig 00, which is in the Madurai part, it's 4 networks. So I'll give 4 address starting from 4, say 4.4.1. Okay. Now I'll come here and I will also turn it on. So it's off actually. So okay. Why this is not on? Okay. I'm just turning all the interfaces on. So, okay, so that's why this was not on. Okay, now only this is left. So let's go to, so this is done. So almost we are through, only one router to configure. So let's go here to Madurai ACAD router. So if you see Madurai router, so gig 01 is connected to 4 and gig 00 is connected to the our Madurai campus. So gig 01, we'll go to gig 01, we'll turn it on and we'll give this 4.4.4 or 4.4.100. Anything doesn't matter as long it's in 4 dot range. Okay. Now let's come to the gig 00 network and this will give it as 5.5.1 and we'll give it as 255.255. 0. Okay. And only one thing is left is come to desktop and what I have given here 5.5.5. Okay. I'm just checking what IP address I've given 5.5.5 for DNS server. So I'll come here and I will just instead of, okay, not this, the server, okay. This I will change it to 5.5.5.5. The default gateway is 5.5.5.5.1, and the DNS server is the same. Okay. Now let me check the services once again. So if we go to DNS, it's 5.5.5. Okay. Let me turn it on, and let me go to HTTP. I've edited that. Okay. Then just I have one more task left, which I'll explain, and then this will work. And IP address is 5.5. Okay. So this is this, and okay. Now it will, now almost it's done, but I have to enable routing. I have to go to the router and say you are connected to these networks and advertise this network to other router. So I'll come to Chennai ACAD router. Okay. And what I will do is I'll use something called RIP, which is called as Routing Information Protocol. So I'll say you are connected to 1.1.0 network, add, and also you're connected to 2.2.0 network, add. Okay. Now I'll close this, and I'll also save this so that I don't want to do all the addressing configuration once again. So I'll come to Airtel Chennai router. I'll tell you are connected to 2 network and you are connected to 3 network. So what Chennai ACAD router will do is, using that protocol, routing information protocol, it will say that I am connected to this 1.0 network, and Airtel Chennai, since we are connecting through the same protocol, it will get information about this network. Airtel Chennai will advertise that it is connected to 3 network, 4 network, 5 network, and it will send it to Chennai router. So ultimately, all the so let's go to Airtel Chennai, and let's go to RIP, and we'll see you're connected to 2 and 3. So I will say you're connected to 2.2.0 network, and also you're connected to 3.3.0 network. If you notice, I didn't say you're connected to one network. I'm just adding networks which are directly connected. Okay, so let's go to Airtel Madurai now. I will say 3 and 4. So if I go to RIP, I will say you are connected to 3.3.0, add, and 4.4.0, add. Okay. Now I'll go to Madurai, our router, campus router, and I will just come here, the last part, and I will say you're connected to 4 network, add, and you're connected to 5 network, add. Okay. Now it's not going to think. Ultimately, we need connectivity. Okay. Now let me save this. Okay. Now I will just move some. I'll do a fast forward so that we get converged thing. So I'll come to Chennai ACAD router just to check something, and I will say I want to check whether we have connectivity from here. So I'll say show IP route. So we have connectivity. So now, if I come to this PC3, first I want to, before going to browsing, I want to check whether I have connectivity to this 5.5.5.5. Okay. Now, if I come to PC3, there's a tool for it. So let's go to command prompt, and let's say ping 5.5.5. So first, initially, the packet, 2 or 3 packets will fail, and then we'll have connectivity. See, we got the reply. Now, so now we have to see whether we have connectivity to. So if I go to, I just want to check what IP, the DNS name I have given. So the DNS name is tnsdc.com. Now, if I go to this PC, the packet should flow from here to from PC3 to switch, from switch to switch 1, from switch 1 to Chennai ACAD router, from Chennai ACAD router to Airtel Chennai, from Airtel Chennai to Airtel Madurai, from Airtel Madurai to Madurai ACAD router, then to switch 2, then to server. And then the return traffic should come from server to switch 2, that's the same path. Okay, so let's see whether everything works and we'll get a reply. So instead of actually we'll do this. We use DNS server, and DNS server translates that to IP address. Okay, and let me just check once again the configuration of DNS server. I don't want any troubleshooting to be done. Okay, 5.5.5. Okay, so let me come here and let me go to web browser. And I will say www.tnsdc.com. Okay, so we got that. Okay, welcome to TNSDC. Now let's see the packet flow. Okay, so let me save this and see the packet flow, and then we will end the session.
Anand sir, a quick heads up. It's already 3 p.m. now.
Yes, just this packet flow and we can answer.
Sure.
I just want to show the packet flow, how it goes. So come here and let me say go. Okay, first DNS thing will happen. See here, so let me. So it goes to switch, it goes to switch 1. We have configured everything. So it goes to Chennai router. Chennai router routing we configured. We said you are connected to this network and that network. So 1 and 2. So it got information from others. So now it goes to Airtel Chennai. Airtel Chennai also we configured RIP. So it goes to Airtel Madurai. Then it goes to your Madurai campus router. Then from there to your switch, and then from your switch to the server. The return traffic will also follow the same path. See, from Airtel Madurai to Airtel Chennai, Airtel packet router. So this was the DNS packet where we got the IP address. Now we start our IP communication. Yeah. So the same path will. So and then you'll get used to it, and then also once you practice in packet tracer, you'll get to see all the features. Okay? Because you were using the chat box, there was some delay. So because I couldn't do it on the same thing. Is there I guess there are a lot of things I could have covered DHCP and other things, but because of the time thing, I didn't cover it because I have to explain what is DHCP, how it works. It is just a simple thing, just to create your interest in the field of networking. Okay, I'll stop my sharing, Anurag sir.
Okay, thank you so much, Anand sir, for your session. So students, if you have any follow-up questions about this session, please reach out to your faculties. If you want to know anything specific in Packet Tracer, how to use Packet Tracer, please reach out to them. We are connected with your faculties, so your faculties are your one point contact, who will convey all your questions to Cisco. So looking forward to receive the feedback about the session and also about the follow-up questions on Packet Tracer. For next following weeks, following 3-4 weeks, every week we are going to do 2 such sessions from CCNA. So every Tuesday and Friday we'll be doing the session. Timing will remain the same, 2 p.m. to 3 p.m. You will get further details and about the exact topic we are going to cover, who is the speaker. You will get all those details through your colleges, your college faculties. And Gautam, anything else you want to cover?
almost we have covered everything, sir. Thank you all. Thank you so much. Thank you, students, faculty, and SPOCs for attending this session. Shall we wind up the session, sir?
Yes, we can wind up the session. Thanks.
Thank you.
everyone.
Thank you.
Thank you, Anand, sir. Thank you,
Thank
Anand.
you. Thank you, sir. Thank you.
Sir, thank you.
Thank you, sir. Thank you. Thank you, everyone. Bye.
Thank you.